All right, we are going to get started. Happy April Fool's Day for those who celebrate. Um, we'll be mostly serious today. So these are real 8 tips. Hopefully you can take away and take to your companies as you grapple with securing AI, which is something nearly everyone's grappling with today. A few housekeeping items, so feel free to ask any questions in the Q&A or chat. We'll get to as many as we possibly can. I already see one question. Will there be a recording of this webinar? Yes. So a recording will be made available if you can't listen in the whole time. And with that, let's get started. So my name's Noah. Happy to be joined by 2 experts from the Oligo here. We have Mick McCauley, who's our field CTO. Mick is talking to security leaders and practitioners all day, every day, it seems, 24/7. So it has a lot of insights to share around how many people he talks to on a daily basis are thinking about securing AI. Really great perspective. Avi Lumelski is our resident AI expert here at Oligo. So not only does he know everything about frameworks and models and inference servers and everything else you'll learn today, but he also is hands-on with these tools and also is a big-time security researcher understanding vulnerabilities and weaknesses in all of these new AI tools that have become really popular today. So really great perspective from Mick and Avi. I'm excited to hear from them both today. Just to set the stage very quickly, we are in the vibe coding era. If you're not familiar with this term, neither was I until about a week or two ago. We put a new post on the Oligo blog about vibe coding. But suffice to say, people are using AI to really build any type of application now. And it really doesn't matter how much software development expertise you have. The use of AI is starting to very quickly introduce a lot of influence into the way applications are built and behave. A few interesting predictions here. So the first one was a few weeks ago. The CEO of Anthropic, a very large AI firm, predicted that 90% of code would be written by AI this year. It's a very bold prediction in my view, but who knows, maybe not too far off. We have a couple from Gartner here, a little bit more pragmatic and conservative with their predictions, of course. But I thought these were interesting. So AI will replatform 50% of legacy apps in the next 3 years. And perhaps most relevant to today's conversation, 25% of enterprise breaches would be traced to AI agent abuse, again, in the next 3 years. All this is super interesting. Last thing I'll say is OpenAI raised $40 billion today. If that's any signal that AI is really picking up along with their staggering daily average users count, which I don't know off the top of my head, all this is happening really fast. So it's a very timely discussion. Really excited to talk with Mick and Avi here. So let's segue right into these tips. And I'll start with Mick on this first tip, which is all about securing production workloads for AI.
Awesome. Thanks, Noah. Yeah, I'm excited to actually have this chat. And again, between Avi and I think there's quite a few ideas and components that we definitely wanted to discuss and share. I'm going to start with the very beginning, right? The actual focusing on production workloads. And probably one of the more interesting aspects to me is the fact that even though AI is new, it's very complex. There's many moving parts. We'll talk about some of those, the inference servers, the data stores themselves, the actual models, as well as a lot of the components and the inner workings of it. When you start to peel it back, it's still just an application. It's still just code. It's still just built on the same components that historically we've built things on. It's just doing things a little different, right? It's using the algorithms and the models to actually perform activities that have been historically not easy to do. But leveraging those to actually build something that can do new activities that weren't available is what AI is actually giving us. So with that idea, one of the things that you need to realize is that most open source AI engines, frameworks, inference servers, like all of these components are built on similar coding practices that have been used historically, right? It's all open source components underneath it. So realizing those open source components are sort of the foundation that all of these engines are built on, you need to take the same approach that you have historically to making sure that those components are secure. And there's multiple layers to this, right? It's not just the open source themselves, but AI and its rapid adoption. The early releases of it were focused on research and giving these PhDs the abilities to perform all of these activities. And so a lot of these open source components that have been built to perform those activities weren't always built with security in mind, right? And the fact that a lot of the defaults in a lot of these engines, components don't necessarily have a security focus. They were meant to be used internally, within controlled areas. And so what we're starting to see is that as we move more and more to these production sort of workloads, there needs to be a focus on securing those. So that's the idea of one of these first approaches, right? Like PyTorch itself is built on the Python coding language. Once a Python process is running, it can perform all activities that Python code before. Now you add in the indeterministic sort of capability of AI and LLMs generating components that might be used by the application. You need to factor in some of those controls and provide some observation and make sure that's not a deviating from those. So a lot of these things start to come into play. So the first sort of idea is let's look at those AI, all of those components, look at the foundational sort of core components and focus your security on it just as you've done historically. Look at all the open source components, know about the vulnerabilities, know about the risks that are there, identify them as early as possible and apply sort of remediation strategies to those. With this undeterministic nature, right, and the free form sort of capability with AI, it's also extremely important to start to look at those production workloads and look for anomalies and deviances in behavior. The fact that we'll talk about sort of many different ways that potentially this framework can be abused, you want to have sort of a framework to look for some of those anomalies actually occurring in your running applications. There's, again, many different moving parts. We'll touch on quite a few of those as we progress through here.
Yeah,
Awesome.
definitely, Mick. I can also add that, as you said, I'm highlighting the thing you said in the beginning about AI being just another application in your workloads. You run them and connect them to your other workloads, and therefore they need security just like any other application that is running and can access all sorts of resources. And not only they are insecure by default, but basically we also recommend like looking at what's in production at the moment and start by securing the production workloads and later on move to the left side because you have a lot of models, you have a lot of researchers. Only 80% of models and experiments actually reach production.
Right.
So this is why you should clear the noise and focus on what's currently exposing you and is user facing, which is more worrying by nature.
Yeah, you're spot on. And the idea that, embedding AI inside of an application and applications by default need to have access to all of the information typically to perform their activities, that AI engine potentially inherits some of those controls, which we'll talk about as we progress. Cool.
Awesome.
Next slide,
Yeah.
Noah.
Yeah. So least privilege access for agents. Avi, what are your thoughts on this one?
Yeah, so I have a lot to say about agents. In general, let me begin by explaining what an agent is. It's simply an LLM connected to a piece of code, or whenever you wrap an LLM and let it choose which code can be executed, it makes it an agent because it can operate by itself. It has all sorts of data sources, whether it's organizational data lakes or some APIs, whether they are paid or open source. So they're connected to a lot of things, and the notion or the idea of connecting an application to an LLM and not by itself, but enabling it to act based on its own will makes it an agent. And they're non-deterministic by design. They're unexpected. They're capable of doing anything. And just like the classic principle of least privileges that exists basically everywhere in security, it needs to be applied here as well. Let's take an SQL agent, for example. Let's say you have a chat and you want the chat to be able to execute some SQL commands. So instead of giving it an admin user because it's easy or convenient or simply works, you should strictly confine it and only carefully allow it to do certain tasks. For example, if you don't need to read or you only need to write, so make it a write-only credential. If you don't want it to delete or write, so use a read-only user, and vice versa. So this is just one example about an SQL implementation before I dive into the rest. Now, often when we're talking about agents, so we connect them to many sorts of tools and let them choose which tools they can activate. So here, if you have two applications that are doing two different things, you don't need to give them access to the same tools just because you already implemented them. You should only give the agent the specific tools that are required to accomplish the task, and maybe think about new tools if you feel that the current tooling is not enough. Basically, agents can be monitored only in the runtime because, as I said, they're non-deterministic. So if you try to check or security assess it in build time, it would never guarantee like anything about the state of its execution or what it will do in production. Therefore, again, it emphasizes the risk on runtime security for agents specifically. And there are challenges, but there are many tools that are available to confine agents, which we'll dive into a bit later in the presentation. Another thing to keep in mind that often agents write their own code. So if you have a Python interpreter, like many SaaS AI providers provide, so they run it in a strictly confined sandbox. If we look at OpenAI or Google, so whenever they run Python code, they run it in a strictly controlled environment that's like standalone, and it does not live past the single execution. From deep diving into it, I can tell you they're securing their workloads specifically because they're multi-tenant, and it's very easy to do it if you only trust the model to not do a certain thing. But the point here is that you need to like implement the least privileges principle in the infrastructure and not only in the code. So again, if we have 10 tools and not all of them are relevant, give only the relevant tools to the context and to the specific application. And make sure to monitor what it's doing in runtime. After you have the visibility of which agent is accessing or which application or container that's running it is accessing which resources, you can confine it and understand it better, but it begins with the visibility and then try to reduce the privileges to the like the strictly the better. That's like my take.
Now, it's this one's always very interesting to me because when I think about this, I tend to visualize things. And this one to me almost feels like having a real-time live developer inside of your app at any given time with the ability to write any code that they want and perform activities that they want. So having sort of those constraints to make sure that they stay within their guardrails is sort of the key element of what needs to happen as part of the security process.
Yeah, definitely. I totally agree. And another good example is when you have many users. Like many applications today, in SaaS, you often have a multi-tenant environment, and you don't want the agent to be able to access to all the users or all your clients' data. And basically, the same rules of authorization, authentication, or non-human identities, and all this market is sort of like swallowing like agents as well because they can perform, they can do all sorts of things. But it's important to understand which agent is doing what, and like if you have 10 different applications, as I said before, each of them can be very well be predicted. Like you can confine them without thinking or overthinking it. It's relatively easy, and I think this is the first step before diving into all the rest. Like before we dive into the inputs, the outputs of the models, and how you can confine this transport channel. First and foremost, you need to make sure that when agent will go wild, and LLMs tend to go wild, and you should always assume that user can impact the state of the application. So you simply need to be able to sleep at night by knowing that it will never be capable of harming you or making defacement or stuff that's like very unintentional. So it all begins with the infrastructure. Again, production is most important, and then focus on the rest. But begin with the infrastructure, and then later on, we're diving into the other parts of the model itself and everything else.
Yeah, makes sense. Start with the protection of the workloads, and then the identities, in this case, agents. Let's move on to this one, Avi. Your thoughts on just simply identifying your use of GenAI. What are been your observations there? Because this is exploding, and my take is people are really challenged with understanding simply all the models and different AI infrastructure that's already being explored and perhaps in use in applications today.
Yeah, so I think that it's very important, and it's a very important metric to, or not only metric, but a piece of data that you always need to have on top of your mind on which models I'm using, and not only that, and all the supply chain and everything else, which data they were trained on. In other words, we have a traditional supply chain problem in build time of models whenever they're trained or fine-tuned. And most of the time, you're not using like a golden image of a model because you simply download it from somewhere, usually from Hugging Face, and you're unable to tell whether it's poisoned or not. But you want to have a clue, like every aspect of security, what is running. So we begin with the visibility. And here, traditional SBOM, software bill of materials, is simply not enough. Especially if we're looking at build time. So as I said before, 80% of models don't even reach production. So you'll be creating tons of technical debt that's not even real, and lots of false positives if you try to patch or update some old models and later on understand they're not even being used in this application. But as I said, software bill of materials is not enough because you have many other aspects, and there is some new animal called AI bomb. Sadly, it's not strictly defined yet, and it's not very well adopted, but there are some companies and parties that are working on the standard in order to make it slightly easier for enterprises to understand how AI is used and where. But basically, all of them try to combine the essence that you need to know which models are being used, whether they're hosted models and you host them yourself inside your cloud or workloads, or whether it's a SaaS provider like Anthropic, OpenAI, Grok, and so on. Besides the models that are being used, and what is the communication channel? Like, does it leave my organization? Like, if I have a private identifiable information that I do not want to share with OpenAI because I'm obligated to all sorts of contracts, and I simply cannot share with them because of policies and regulations. So you're in a problem. You need to host your own models, or you need to make sure that if there is the slightest chance of that happening, you need to implement something that will assure that no private information is leaking. And there are models and AI that is specially crafted for this task and is being used. So it's a fun effect, but models are being used to validate the outputs of other models. So usually you have a big model, a large language model that's very like robust, and you have a small model which just goes over the inputs and the outputs. We'll get to that later. Not only in terms of security, but often in terms of like data leakage, which we'll also dive into slightly later. And besides the models and data sets, you also have the prompts. And I suggest, like, and I recommend to have a centralized a storage or a warehouse where the prompts can be accessible and carefully reviewed, because you won't believe what the slightest change in prompt without diving into prompt engineering, what the slightest changes in a prompt can dramatically increase, decrease, and impact their performance for the good and for the bad. And by having them centralized, you can basically assess them and try to improve them security-wise later, and it will be much easier than to have them spread across different Git repositories and pieces of code or configuration files. So prompts are important. We'll dive into them later, but besides the prompts, you need to carefully also review which permissions each one of these applications that connect the model to the hardware or that wraps the SaaS provider that you're communicating with. You need to carefully review the permissions. So if you don't want any sensitive data to leave the organization, make sure infrastructure-wise that it's not possible in the first place. And carefully review the permissions that each application that is GenAI based has and is granted. Now, 80 to 90% of the time, you can tell what models you're using. Thankfully, most of this ecosystem is based on Python, and it's object-oriented. So the libraries and the top libraries that are being used and also recommended by AI models themselves are very straightforward. So if you know which functions are running or what are the names of the classes that are in use in the code, by code scanning or by using an agent, it does not matter. But as long as you can tell which models are, which classes and functions are running, you can imply on the models that are being used. And that's a huge fact. And for example, in the transformers library, for the ones that are familiar with it, you have a class for every kind of model, whether it's a Q&A model that answers questions based on queries, whether it's a chat model, a classification, detection model, and so on. So you have all sorts of interfaces, and usually the models are stored also as part of the code. So you always create a query to specific endpoints, and the endpoints also include the nature of the model that is being used. And basically, all this data is very accessible, but sadly, there isn't like a wide adoption to AI BOM yet. So I recommend like a runtime SBOM or a software bill of materials that's like more focused on something closer to your production workloads, if you have one. And basically, it will tell you which models are actually being used in user-facing applications, not mentioning like everything that's currently in development, but the most critical threats. So a runtime SBOM can list almost like 80 or 90% of AI usage and GenAI usage across your applications. And that's it. So besides like the OpenAI Python library and transformers, there are tons of other frameworks. But if we look at the 80-20 rule, most of them are using the same boilerplate code or the same SDKs, and they are very easy to monitor. And we also like use the same notion, and by understanding which code is executed, trying to understand which models are being used. And sometimes you don't even have access to the code, so you just have to like use someone else's AI, and this is also where like runtime like SBOM comes in handy.
Let's move
Cool.
on to the next tip here.
Yeah,
This
and
is all
as we
about
do that, sorry, no, I was just gonna add, like everything Avi just said, one of the things that sticks out to me is you can't secure or know what your risk is for something that you aren't aware of. And so that AI bomb is one of those first things, which is it's all about visibility. And as sort of the evolution and discovery and disclosure of risks starts to become more prevalent, right? Like if there's known model poisoning and somebody starts sharing it, knowing whether or not you're using it is going to become a core requirement in order to actually apply some of those restrictions. So we'll see this evolve, I think, as AI is more adopted, but I see that as like a very, very prominent sort of focus, just as we have with open source.
absolutely.
Yeah.
Cool. Let's talk about the actual output of these models. Mick, I think you had some insights on this one.
Yeah. So this is where we start to get the meat of actually true AI, right? It's the information and the content that it actually creates that you start to utilize to your advantage, right? How you build this into your applications, what sort of LLMs that you're using in order to actually find information or create or generate new content. There are some security risks associated with it. One of them we just talked about, right, is the fact that, you know, if the model's poisoned, then the data that's coming out of it is going to be subject to that information as well. So, and in some cases, it doesn't have to be poisoned. It's just the model was built on a data set that has information or data that it can create, which could in turn be used against you. And so this goes hand in hand with, I think, the agentic AI that we talked about before, because if those agents are working on the output generated from an LLM, if you happen to abuse the LLM to actually do something maybe it wasn't intended to, but it has the capability of doing, then it can start to perform those activities without sort of your control. So the idea here is, you know, with these non-deterministic sort of data sets that are going to be coming from output, is start to inspect that, start to understand sort of how it's going to be used, and make sure that if your code is being used on top of the output, you almost have to assume that it's just like input coming in from your end users. Assume it can have malicious sort of data in it and be able to act upon that to ensure that you're only performing activities or utilizing to its best of advantage. So there's a few approaches to this. And again, this is where, you know, using LLM to actually perform activities, and Avi mentioned this before, like SQL injection, cross-site scripting, where you can use the LLM to actually generate the code that your agentic AI then performs the activities and gives you information that you weren't intended back. But there are some approaches to actually help and secure this. Like one is to, again, apply business logic associated with it. You know, sanitize input, validate input. There are solutions and tools in the market that are built already to start to perform some of these inspection capabilities. Meta's Llama Guard has some of this. If the LLM, the intention of it is to actually create code, there's some solutions like Code Shield that are out there that allow you to actually do some of these types of inspections. But the idea is to simply let's validate it. Let's just assume like it's going to go outside of the controls of the things that we want it to do, and make sure that you're putting in some of the controls and protection places inside of it. So another layer, right? Like embedded inside of it. The more controls you put into here, the more less risk that you're going to have that your engines may start to perform activities that they weren't intended to.
Yeah, and also like regarding like any application, basically the outputs are very critical, and if you act upon them, you have to validate it. Like any web application, like every API that you develop, like every application that's only living in the backend, nobody has the right of not validating the data. If you work at scale and the user has any ability to modify the arguments or potentially affect the application flow or the context that the LLM receives. So any like injection attack that that was possible before, the same applies here because it's a non-deterministic system. As I said, if you didn't have SQL injections, or if the LLM refused to help build a bomb in the build stage, like after training, it does not mean that like 1 year later or a week later, with the pace of today's progress, there won't be an open source prompt somewhere on GitHub or on Twitter, which jailbreaks your model and makes it output nonsense. And sometimes it's not that like critical to some companies. Like there were lots of enterprises that wanted to adopt GenAI as quickly as possible, but ended up getting like compromised because of that, and bleeding money because their chat was able to do anything, even write Python code or writing stories, and it definitely not something a support chat should be able to do. So it was like the early days. Then there were like a month or two, or like slightly longer, in which all the enterprises pulled back, holded their horses, and basically tried to reassess their approach towards the implementation in production. And only after they had sufficient guardrails and when the community was slightly more mature, in the essence of security. Only then we saw GenAI in production, and it's been a while, but to this day, if you don't have an attack running today, so it's like I don't know. You have all sorts of like surprises that simply a way to be exploited, and it's only a matter of time until people come up with a new prompt that will bypass any existing protection. Just like when you have a web application firewall rule that does not allow certain transport to be passed. So in the same way, you have bypasses to everything. Like we've seen, sometimes you don't need like any special ability in order to bypass a firewall, and it can be even cross-vendor if it's something very novel and sophisticated. And the sad truth is that with LLM, it does not have to be this sophisticated. It can be only about like 10 characters of emojis, or specially crafted like invisible UTF-8 characters that can affect the entire execution flow. And even if you only use like the slightest piece of information, the user's first name, and it can modify it through the settings. So you have to keep in mind that this context can propagate and leave your organization as well. And that's something you want to strictly control. And basically, like that's it. I think we can move on to the inputs, right?
It's funny for this one too, just like I did with the other one. For me, I visualize this as just another, like it's almost the potential to create an attacker inside of your app, right? Because the output that can come from it could be malicious or harmful in any sort of way. So you have to kind of envision that that is one of those vectors. And the same thing that we've already talked about many times before, but because it's non-deterministic, you don't know what's coming. So if you don't know what's coming, you have to assume the worst in a lot of cases and plan for the worst. And that's sort of what this output, I think, shares to me.
Definitely. And also, like, last point on this one is that it's a hard problem because it's not deterministic. Like this fact just breaks all security assumptions made when using and handling static codes, or like reproducible and like predictive like behavior of systems. Here it's simply inconsistent. So if you have a compiled code and it's told to do this and that, and it has a clear branch tree, and you can trace the entire execution, and it's very, very predictable, and most of the time it's even static. In here, you would never know what will be the output of the model. And not just that, like it happens to me personally that many times the provider just switches the model without like letting you know in advance. So I have a model number or named A. And then like after a month they update it, but it does not necessarily perform better on my task, and I cannot roll like back to the other model, like to the old model. Or sometimes they deploy newer models which are less secure but more robust, and it's not your preference. So you basically need to assume that the model is the wheels, like the drive, like your car, and they can be replaced like at any time by the SaaS provider if you use like a remote model, and you simply need to be in control. And it's also another like big point of like supply chain compromise and like exploitations.
Awesome. Friendly reminder, if you have questions, please put them in the Q&A chat. We'd love to get to as many as we can. But we also want to cover all the tips as well. So if you have questions about anything Maker or Avi have alluded to, please put it in the chat or Q&A, and we'll do our best to cover it. With that, let's move on to the next one, which is all about prompt injection. I think we've touched it a little bit, but a little bit more in depth here. Make any thoughts on your end on prompt injection?
Yeah, and Avi mentioned this earlier as part of some of those discussions when we were chatting earlier. When you start to look at sort of all of these interconnected components, the first thing that is one of these threat vectors is the fact that you've got data coming in, right? Like as you're starting to use these LLMs, you're feeding it information in order to generate content. Where that information comes from is extremely critical, and what that information has is extremely important, because as Avi mentioned, a lot of these LLMs are built to perform specific activities. However, you can use them against themselves. You can send specific types of requests or ask it to perform specific data. Or there's many, many examples of jailbreaking engines, right? Like asking the LLMs to do particular activities that they're not supposed to do, give you access to the prompt or perform some sort of queries. So this is like, as you start to look at the kill chain, this is like one of the very first areas that it's like, let's actually start to like provide some levels of protection. If we can control the prompts, if we can control the incoming data that's going to make it to our engine, that allows sort of, infinite possibilities of things that it's going to create from an output perspective. If you can control those, you can start to control your security risk. And so the idea here is, and there's multiple layers to this. One is the LLM being used against itself. The other is if for whatever reason the data being ingested also is becoming part of your data set that the LLM is going to use and be trained on. Like there's multiple sort of facets to how this information could start to impact you negatively, right? If it's the input that goes in the data set, you can start to do poisoning of information. If it's input that is used to actually have the LLM perform activities that it's not, you can start to perform SQL injection and some of the other things that we talked about with the agentic AI. So the idea is to say, all right, we've got our first layer of input. Let's actually put some controls in place to help do that. So there are some tools that allow us to look for those types of attacks. Some of them are built into some of the AI engines and frameworks themselves. Meta with Purple Proxy, like the ability to actually have almost like a WAF in line with your LLM, of being able to actually look at the input data and then perform activities based upon it. Still much like a WAF where it's rules based when you're trying just to catch things to, head them off before they're able to actually attack. There's free tools out there like Prompt Guard, which allows to perform these types of inspections. As Avi mentioned before too, some of those are actually LLM based themselves, right? They're using sort
like
of
a very small model,
small models to actually identify the attack models in the prompt. So you're actually using LLM to help protect against LLM attacks, which is very interesting. But all of these are sort of ways to actually help you cut off. And then as Avi mentioned too, like if you can predetermine a lot of those types of prompts, you start to eliminate a lot of this free form access controls that those prompts can then be used as part of that process. So the idea here is again, early in the kill chain, identify those. But again, if whatever reason, because you can't always find, discover, and build rules for every single potential, what you still need to do is to look for those deviant behaviors associated with what those things might result in. And this is one of the common themes that you'll see through this talk track is that, still observing or looking for anomalous behavior, deviations, characteristics where you can tell things aren't happening that should be. When specific processes start executing code in your server, these are telltale signs that you can identify that things have gone awry. And if you can't predetermine every single rule to try to catch those, you still need to have this ability to actually detect that, block it, and stop that. And so these are some of the approaches, and you'll see as a common theme through all of these, it's just different layers that you can start to perform these activities. The prompt is one of the very, very early ones.
Yeah, and there's also like another slightly more sophisticated attack in which you take leverage of the fact that the LLM queries a specific API, like when searching. So whenever you ask some LLM or chat-based interface to search something for you or find the best flights, so it has all sorts of integrations, and usually because the second you stop training the model, it loses like relevance, and like any second that passes beyond the trading, the moment the trading stopped, is like a lost space for the model. It simply is not aware of the facts coming after that, and there is like a knowledge cutoff. So you have to connect the model to more like relevant sources, or let it execute like sorts of tools, like we said before, when you're using like agentic workflows. So there are many tools that can be used. And these tools often can like inject stuff into the content. We talked about the outputs before, but if you know that something is going to be searching, and you know how it searches or how it scans a given website, and you're able to propagate your like paragraph or your piece of JavaScript code or something to the model. So it can really mess its thinking, and it can result in like an injection attack. This is called indirect prompt injection. It's basically the idea of anything that's not based in the original prompt, like a template, but in the context that is attached to the prompt. Like if we have a string formatting to the prompt, and it has all sorts of like variables in it that change with each query. So in that essence, you want to be able to like confine it well, and keep in mind that if it's coming from external resource or something that's like not in your control, a third-party API. So you simply have to trust it less and keep in mind that it might like misbehave or propagate to the main application context. And this is where things like can tend to go like messy.
Yeah. We got one good question. Avi, you might be more familiar with prompt guard, but the question was around prompt guard and what does it typically do? Is it just validating the input data, or is it performing other functions?
It's a great question. So if you had in a traditional way, let's say you ask a model to build a bomb for you, or a recipe for something illegal. Let's stick with the bomb example because it's very easy to understand. So if you would have trained a model to like simply look up for the word bomb existence in the context and block it like this way, so it won't do, because if you switch language, or if you use another like analogy for a bomb, like build something explosive. So the traditional like way of writing rules is simply not sufficient, and you have to keep you have to be aware to the embedding space, which is something more abstract, but it's like more of the lexical meaning of the word, the essence of the semantic inside of the word or the sentence. And then if you ask for something explosive, or if you ask it to build a bomb, for this model that critiques the inputs, um, for him, it's something like familiar, because it's very, very close to something else that it's seen before, and it knows to classify it as one of like several things. It can be a jailbreak, it can be offensive like language, it can be like forbidden terms or something like that, and you can actually train your own model. And they not only use like LLMs and sorry, when you have LLM as a judge in many training systems, so it's kind of the same idea. You take a model, not necessarily a large one, it can also be a very small one. You train it to detect famous attacks, such as then do anything now, or asking the model to begin its answer with sure, and so on, which kind of tweak the model into behaving in a certain format based on the way it was trained to do. And all these techniques are usually catched by this model. But as I mentioned before, like a week later, 2 weeks later, someone can come up with a new technique, like using emojis or something like that was not seen before. And then you're still in a problem. So it is important. It is not sufficient. As I said, you have to secure your infrastructure as well. And least privileges like helps here as, by far. But like, does that answer the question?
Yeah, it does. That's great. Defense in depth. Prompt guard is one tool in the arsenal here. Thanks, Avi. Cool. Let's move on to I think we have 3 tips left, so we'll try and cover them in 5-6 minutes here. Shadow vulnerabilities. Mick, I think you also had thoughts on it.
Yeah, so I'll keep this one brief, although it could be a complete talk, and it has been before for us. Because the idea of shadow vulnerabilities is something that we actually disclosed, and Avi presented at Black Hat a couple of years ago. But the idea is that sometimes there's vulnerabilities that aren't something that is like a CVE that's published that you can simply scan and identify. And so there are some, vulnerabilities that have been discovered that, the maintainer has said these are not actual vulnerabilities. The security controls are embedded inside of, in this particular example, in open source libraries. If you don't use them properly, that is your own fault. And again, as open source is used and is built on top of, not everybody knows all of those specific details. Sometimes you get the inherited risky sort of permissions. And then when they make it to a production workload, all of a sudden you're exposed to a vulnerability that you cannot inspect for. So the idea here is to look for the fact that if these happen to exist, what results as part of it is usually a successful attack. There's a vulnerability that's exposed that an attacker can actually abuse to perform activities like remote code execution. And so looking for the activities associated with the anomalous behavior, remote code execution is always extremely important. It's almost a form of an unknown vulnerability, which goes hand in hand with the exact same description that I just shared. It's like looking for some sort of deviation in application behavior that is a telltale sign your application's being used against you to perform activities. So shadow vulnerability is a whole topic on its own, but it's one that's extremely important to know that regardless of the application, and most AI is built on these exact same open source ones that have these shadow vulnerabilities. And we've discovered and disclosed, and again, have actually multiple blogs on discovering AI engines with these shadow vulnerabilities inside of them that were subsequently fixed.
Awesome. Yeah. Shadow Ray was the big one. If people aren't familiar with it, head to the Illumia
PyTorch,
blog.
Keras, we've got multiple blogs on a lot
it's
of
like
those that.
like almost any framework like included some sort of vulnerabilities. Many times it's like a very simple idea that the AI code is relatively new. It's been reviewed by very few eyes, and it's also written by people that are usually researchers or LLM developers and engineers. They're not security practitioners. They might be like if they're more familiar with engineering, like secure engineering or defensive code development, but they don't have security in mind. They have ease of use and robustness, and get things up and running quickly because your users are very lazy. So they won't be forgiving you if the installation goes wrong. So you want things to be running smoothly as fast as possible, and this is how security loopholes create.
All right, two left. Avi, thoughts on inference servers?
Yeah, so mentioning shadow vulnerabilities, there are lots of different inference solutions. So inference servers are basically the component in which you wrap the model, and it takes care of the connection to the hardware, whether it's the GPU or the CPU. The thing is, whenever you rent such expensive hardware, expensive because it needs a lot of compute power, and it's simply expensive if you buy it or acquire it on demand from a cloud provider. You want to utilize these to the fullest. You want to squeeze the juice from the hardware, and the only way to really do it is not by having the model placed inside of each application that uses it. You want to have a single deployment of the application. It might be scalable and distributed, but at the end of the day, you want to have a centralized way of querying a model. There are lots of APIs. The very prominent one today in GenAI are OpenAI's specification. But there are all sorts of other tools which I'll dive in soon. But the idea is that you want to leverage the hardware best, and you have to write code that wraps the model and connects it to the GPU. And most of the time, this code is Pythonic, and it's not confined at all. Since we're talking to GPUs, and there are lots of driver usage, very messy installations, and it's hard to set up an environment or create an image that even works well with all the dependencies, not overriding each other's other dependencies. So get things up and running is very hard in the first place. Inference servers allow you to do it in a centralized way. And by design, they're not built for security, they're built for performance. So they're doing a lot of like decisions that are compromising security in favor of performance to get more frames per second, to get more queries per second, or in order to answer queries faster. So they're optimized for throughput and latency. And whenever you have a communication channel between like two inference servers, the idea is that you want to confine it and make sure the communication channel is secure. And also you want to make sure that it does not expose any management interfaces or something that was unintentional, like we've seen with like ShellTorch and Shadowray. So many like frameworks basically expose the server to the internet. It exposes like an API on top of a model, usually in HTTP, gRPC. Sometimes if it's in the same workload, so also like shared memory, but it's usually over the network. So these things are connected to other workloads and other components that query them. And if you just have access to an inference server, you can run arbitrary code on the inference server. All you need is a single vulnerability, and usually they're using very, very high privileges because, as I said, they need access to devices and stuff that is very hard to confine without using like an overprivileged account. And therefore, they're very prone to exploitations. They're goldmine for attackers because if you hack into an inference server, you can see the model, you can see all the prompts that are being received and returned, and you can basically alter its behavior. And this is how you can have a very, very like a concerning backdoor without even knowing it. Like imagine a shadow vulnerability in inference servers. That's how you can like infiltrate organizations. Because as Mick said before, many shadow vulnerabilities are intended behavior. You won't be seeing like a CVE for such vulnerability or such attack vector. And they make a lot of dangerous assumptions. So whenever you implement the inference server on your own, please make sure to read the docs and try to use the state of the art because it's usually more maintained. And there's just plenty of new code when it comes to serving and the inference of models. That's it. Like carefully select your inference serving platform and make sure it cannot go wild, and make sure to run it in a confined way in a trusted environment that cannot be like accessed externally. Don't expose them to the internet if you don't need to, and so on.
Awesome. Super interesting and fascinating that this will probably be the most kind of targeted asset from attackers in the years to come. Last one is around data leakage. Maybe an obvious one, but not so simple for AI models. So Avi, any last thoughts on this one?
Yeah, so data leakage is like how to detect because, as I said, usually the data resides when we're talking about leakage. So it's either leaking it to an external provider or leaking like internal data to external provider, or the other way around, when a user is able to leak data from another vendor or something that is simply not supposed to be visible to him. It's very hard to tell based on the inputs and the outputs whether this data is valid or not. It's hard to classify. And the best thing to do is basically define a policy of data access. And it's like the access layer where, like, if we're talking about inference servers, like in the previous tip, so here we're talking about like servers that the LLM can access or data that can be propagated to the LLM. If you have like there's something new called an MCP server, so a model context protocol. It allows it's defined by Anthropic, which pioneered it, and it's being like very widely adopted. It's like a centralized way of securing and not securing, like defining ways to enable LLMs to query certain tools and use tools in order to accomplish a certain task. And thankfully, it's like centralized, and this is where like data is being accessed. This is where this is like the LLM's API to access the data. And this is what you want to confine. And usually it's just another Python server that is receiving requests over HTTP or other kind of transport and acts on its behalf. So those communication channel can always like leak data. So you can either use a small model to determine whether there's some nature of content in the response. You can have static rules, but it's like a cat and a mouse game. But yeah, basically you need to like implement the filtering logic and sanitize the inputs, the outputs, also for data. Like if the focus is compliance or if the focus is not leaking like someone else's like credentials, so it's relatively easy to say if a prompt includes the username and the password, but it is not necessarily easy to determine whether it's including like something very abstract. So it's hard to confine. You just need to have a centralized way of accessing the data when we're talking about LLMs or vision language models. Also, if it's a vision model, so it's hard to say whether an image contains certain content. Like you can, but this task is much more robust, and the research and the community is much more like suitable for text at the moment. Like vision is not there yet when we're talking about confining it. So embeddings and text, so they're nice, but with vision it's slightly different. Yeah, like anything else you have in mind?
No, I think that sums it up. I mean, the fact that it is very complex, it's not easy to do.
Yeah, it's not
But the
easy.
ideas, yeah. It was one of the first focuses, I think, for a lot of the AI adoption. It's like, oh, how do we protect our data from going in there? And then how do we protect data that we don't want going out, showing up someplace it shouldn't? So it's a very tricky one, but yes, controlling as much as possible is probably the best policy there is.
Yeah, and the more centralized, the easier it gets. Like many companies are implementing an LLM proxy, so it would gate all the requests to models and see if there's any like leakage in the prompts. This is also a place where LlamaGuard and Code Shield and other components can be implemented. And having it centralized simply helps with the visibility. And after you have visibility, you can detect based on your use case.
Fantastic. A lot of great insights here. Some of these, tips are easier said than done, but hopefully everyone now has a kind of a mental roadmap for how to tackle some of these challenges. I certainly learned more about AI in the last hour than I knew before. So just a couple of parting resources for you. We have an ebook exactly on this topic. Everyone who's dialed in here today will get a copy to their inbox. If you're interested in learning more about all sorts of things around application security, securing AI, and any related topic, head to our academy, so oligo.security/academy. And we talked a lot about runtime approaches and how this can help with a lot of these challenges. If you're interested in seeing the oligo approach to runtime security or application detection response, head to our website and we'd be happy to give you a complete demo on that front. Mick, Avi, thanks so much for your insights here. I learned a lot. Hopefully everyone else did as well. And thank you everyone for your time today.
Thank you all for your time.
Thanks all. Appreciate it.